11th International Physics Olympiad, year 1979, IPHO. I offer private tutoring for Physics Olympiad preparation. I currently have openings. Message me if interested. My email is fred1996@hotmail.com, or you can use Skype name Eduard F. 1996. Problem number 1. A space rocket with mass m equal 12 tons is moving around the Moon along the circular orbit at the height of h equal 100 kilometers. The engine is activated for a short time to pass at the lunar landing orbit. The velocity of the ejected gases u equal 10⁴ meters per second. The Moon radius rm equal 1.7 multiplied by 10⁻³ kilometers. The acceleration of gravity near the Moon surface gm equal 1.7 meters per second square. First question. What amount of fuel should be spent so that when activating the braking engine at point A of the trajectory, the rocket would land on the Moon at point B, figure 1. Question 2. In the second scenario of landing at point A, the rocket is given an impulse directed toward the center of the Moon. To put the rocket to the orbit meeting the Moon surface at point C, figure 2. What amount of fuel is needed in this case? 11th International Physics Olympiad, year 1979, IPHO. I offer private tutoring for Physics Olympiad preparation. I currently have openings. Message me if interested. My email is fred1996@hotmail.com, or you can use Skype name Eduard F. 1996. Problem number 2. Brass weights are used to weigh an aluminum-made sample on an analytic balance. The weighting is once in dry air and another time in humid air, with the water vapor pressure pH equal 2 multiplied by 10⁻³ Pascal. The total atmospheric pressure P equal 10⁵ Pascal, and the temperature is 20 degrees Celsius, are the same in both cases. What should the mass of the sample be to be able to tell the difference in the balance reading, provided the sensitivity is m0 equal 0.1 milligram? Aluminium density ρ1 equal 2700 kg per cubic meter. Brass density is 8500 kg per cubic meter. 11th International Physics Olympiad, year 1979, IPHO. I offer private tutoring for Physics Olympiad preparation. I currently have openings. Message me if interested. My email is fred1996@hotmail.com, or you can use Skype name Eduard F. 1996. Problem number 3. During the Soviet-French experiment on the optical location of the Moon, the light pulse of a ruby laser lambda equal 0.69 micrometer was directed to the Moon's surface by the telescope with the diameter of the mirror d equal 2.6 meters. The reflector on the Moon's surface reflected the light backward as an ideal mirror with the diameter d equal 20 centimeters. The reflected light was then collected by the same telescope and focused at the photodetector. Question 1. What must the accuracy to direct the telescope optical axis be in this experiment? Question number 2. What part of emitted laser energy can be detected after reflection on the Moon if we neglect the light losses in the Earth's atmosphere? Question number 3. Can we see a reflected light pulse with the naked eye if the energy of single laser pulse E equal 1 joule and the threshold sensitivity of eye is N equal 100 light quantum? Question number 4. Suppose the Moon's surface reflects alpha equal 10% of the incident light in the spatial angle 2 pi steradian. Estimate the advantage of using a reflector. The distance from the Earth to the Moon is 380,000 kilometers. The diameter of a pupil of the eye is d equal 5 millimeters. Planck constant is h equal 6.6 multiplied by 10 power negative 34 joule by second.